Hello, let me mute my notifications. Hello everyone. I don't know why. Oh, I know why. My window cam is not right. Is it? I think it's this one. Overhead. Hover cam is not on. Nice. That's okay. Up in the window here, there should be something, but it's switched off, or it's mixed up. Hello everyone. My name is Scott. I guess I'm starting. I started on time. Hopefully you can hear me. Let me actually pause streams here. So, yeah, welcome. Getting going. My name is Scott. I work for Adafruit on CircuitPython. I go by TanNewt online. My brain's a little gone. It's Friday afternoon. So Adafruit is an open source hardware and software company based out in New York City. I work remotely for them here in Seattle. And I work on CircuitPython, which is a version of Python designed for little tiny computers called microcontrollers. And I have this one here underneath this metal part. There's a little tiny computer called a microcontroller. Oh, don't bounce the camera. That is really inexpensive and quite powerful, allows you to do all sorts of things. So CircuitPython runs on this. One way to edit the code is you plug in the USB, shows up as a drive, and has Python code on it. Python is goodnight Bass for cars. That makes it really easy. We also have web workflow now as well, but we won't talk about that today. If you want to support me, you can do it by going to adafruit.com and purchasing little tiny computers like that or accessories for them. I will say hello to folks and I will answer this question. This is a deep dive. It tends to run about 2 hours where you can ask questions and we'll talk about different topics. I think I'm coming down with a cold. I have a toddler in daycare. And he's had a runny nose, and I'm feeling like a little drained and a little stuffy, so I think I might be coming down with that. So if my brain's even further gone today, that's why. But let's say some hellos before I get into what is on my mind. Hello, Beata. Hello, DCD. Hello, Timon. Audio's good, thank you. Hello, Zarnland and MC Quinman16. Yeah, toddler has a virus generator. Yeah, I'm like just getting over a stomach bug that he had last week as well. So it's great. He's fun. What about an RP2040 based microcontroller? Yes, CircuitPython works on the RP2040, and in fact, that's what I was just working on with working on some stuff with RP2040s today. Although it's pretty new stuff. Mark says, I've been debating if my nephew got me while he was coughing in my face while holding him. Probably. I've been like sharing food with Ari, my toddler, so that's fair game. I got a message. Hello, Hams Labs. Yeah, I could feel a lot worse. I'm at work. I could be in rough shape. But yeah, he goes to daycare with 11 other kids. So it's getting a lot of stuff right now. My wife got a call from them today to tell her that he had stuck a pea up his nose, like a green pea that you eat. And every time we talk about peas, he says peas nose. So like, I'm not surprised. And then she texted me immediately after saying, they just called me back. He sneezed and got it out. So yeah, that's hashtag toddler life, is your toddler thinks that peas go up his nose, even though he will tell you it goes in his mouth now. Apparently when he was actually given peas at daycare, he did put them up his nose. Like, I don't know where he got this idea, but we definitely had peas at home at one point and he did 2 peas and we managed to get him out. But freaking annoying, but also very much. How much for one? For an RP2040 based microcontroller, they're inexpensive. The Picos run like $5. So if we go, let me not show this browser window. This is my one with the live streams. I'll pull up the screen in just a second. Oh, and I wanted to make a caveat that I am on Wayland, which is a x.org replacement for the first time streaming. So if it errors out, sorry. We're trying something new here. I actually did the like KDE update. Time for an Adafruit browser. That's right. So here's my Adafruit browser. And we'll go to adafruit.com. And if we just look RP2040, you could see this RP2040 prop maker feather is $20 off Adafruit. It's not the cheapest option you will find, but I'd like to take this opportunity to remind you that paying Adafruit for their boards does fund all of the software work that I do. So even though it's not the cheapest, I ask you to think about Adafruit stuff, and you also get a bunch of support as well. I don't know, the cheapest kind of well-known manufacturer is the Pico, which is the Pico W here has Wi-Fi. It's $6, and then $4 for the original non-Wi-Fi one as well. Rob says, my DIY droid is going to be very spacious host in around an hour. He runs a lot of Adafruit things as well. Nice. Tyeth says, cheap usually means next to no working code except a factory demo and poor/non-existent documentation. That's right. Zarnlin says that ESP8266 can be as cheap as $1.50. That's true, but beware that CircuitPython doesn't run on that. Baspercar says, should I get one? If you're interested in programming microcontrollers, then yes, you should. CircuitPython's a great way to start with that. Zarlin says, I had to switch back from Wayland because Chrome was Crash City on Wayland and plays Plasma 6 KDE desktop. I'm using Firefox, so I have not... I do use Chrome for video chats, and I haven't had a problem. I'm on... I have a Radeon graphics card, which I'm really impressed with the support that AMD gives. I was using it until I switched back to Radeon AMD, and I'm very happy that I did. It just works better than the Intel one at this point. They both have open source drivers, which is cool. MC Quinman says, I bought myself a Raspberry Pi 4 Model B and a Stemma Quick connector on Adafruit, and it comes on the 12th. I'm so excited. Yay! Zarlin says, it could be my very old NVIDIA I have at work. Yep, that could be it. Dishipu says, oink. Welcome to Shipu. Okay, so I titled this stream, so if you have questions, Baspercar says, does it ship to the UK? Adafruit does ship to the UK, but there's resellers in the UK that are going to be a better choice for you, which I think is just adafruit.com/resellers. And the Raspberry Pi is actually, oh, that's not. Distributors? Active distributors in hackerspaces, Europe, United Kingdom. I know Pimoroni is there. Yeah, so if you're not in the US, feel free to use a distributor. Yep, Tyeth says Pimoroni, the Pi Hut, coolcomponents.co.uk, and digikey.co.uk. All of those are going to be faster shipping and not have to worry about taxes probably either. Maybe a little bit pricier, but it also supports us. Buying through resellers still does support Adafruit, and you'll get Adafruit support for Adafruit products that you buy through a reseller. Um, okay, so what was I saying? So I have I named the thing bugs and builds because if you've been paying attention, we got the release candidate 0 of CircuitPython 9 out yesterday. Dan released it. So we're kind of out of bugs to do for the time being, which is awesome. So if we go here, we should see issue count. We can go to milestone and 9.0. And we just have this to-do list that Dan had. I just thought I'd talk about the things that I'd done in the last week to get us there. I'm not the only person. Like Jeff and Dan have been doing bugs too, but I just thought I'd talk about some of the stuff that I did. There. Can you code on the Pi 5? Because I have one. You definitely can. CircuitPython, not so much, because a Pi 5 is way more powerful than a microcontroller. Toddbot says, oh, you want more bugs? I can introduce more bugs if you're out. No, I just, they're not on this list. We have plenty. We have 666 bugs open right now, but yeah, we're switching out of bug mode. We spent like 4 or 5 weeks in bug mode, so I'm trying to kind of switch out of that. It's been a minute, and it's actually throwing me off a little while, so. But I wanted to do that. So let's just talk a little bit about the things that I've been working on that I did over the last week. Because I think at least this TLSF thing is going to be interesting. But first, I did change the web workflows test for writability. So somebody had filed an issue, and thanks to them for testing this out, where with the new changes, you weren't able to use the web workflow, like write via the web workflow if it was just unplugged, like not plugged into USB, but if it was plugged into USB, it would not. So I changed the logic here so that it actually is dependent on whether USB is plugged in or not. That was somewhat simple. So TLSF is a way that memory is allocated. So this is a really interesting thing. It's called Two-Level Segregated Fit Memory Allocator Implementation. So deep dives are all about getting in the weeds, and I feel like the way that this works clicked for me last week or earlier this week when I was working on it. So I thought I'd take a little bit of time today to talk about it. So in CircuitPython 9, we now have what I think of as an outer heap. So what I mean by an outer heap is that there's some code that's maintaining the free memory from the very get-go and allowing us to allocate portions of that as CircuitPython runs over the length of time. We used to have our custom implementation of this, which was called the I don't see anything blocked from you, David. So put it in the Discord if you want me to post a link or something. So yeah, in CircuitPython 9, we now have this outer heap. And the cool thing, it replaces this memory management that we had in the supervisor, which is like the bit of code that we consider to be long running. And then we combined that. So we now have an outer heap. The outer heap is allocated and managed through this TLSF library. And then we now have split heaps in the Python VM. So what we used to do is when you started up the Python VM, everything that was still free, we would allocate to the Python VM. But the problem with that is that you can then no longer allocate something that you want to survive after the VM is done. So what's cool about split heaps is that the free space when the VM starts, the VM will only take up a little bit of it at a time. as it's needed instead of like taking it all at once. So even if the VM's running, we will actually be able to allocate memory that's managed longer term than the VM itself. What we would do previously is we'd allocate to the Python managed portion and then move it. And moving it is like so error prone, so error prone. It's just a really bad way to do it. Like nobody expects memory that's been allocated to move. And we had like hacks and ways of like updating pointers and stuff, but it was really hard to like, basically impossible to get right. Okay, so DCD was also suggesting, if you go to circuitpython.org downloads, these are all the supported boards, and you can just type things like RP2040, although it doesn't show Pico, so like it still has that problem. But you can see kind of like what they all look like. They have different form factors and things. David asks, oh, about USB connected for web workflow. Did you mean USB connected or CircuitPy exposed? CircuitPy exposed, if you disable the CircuitPy drive, then it doesn't matter. But the behavior in 8 was that if you had like USB powered, it didn't matter. But if it was like enumerated, then it would prevent the web workflow from working. So anyway, so popping up the stack, getting my brain back. So this TLSF thing is one way that you can manage memory. So it's like an allocator. And it has these cool properties, and it's kind of designed for embedded stuff. So it's order 1 cost for malloc-free, reallocate, and mem-align. So that means that it's constant time. Which is really good for embedded. It's like a fixed amount of time. Low overhead, which means we don't waste a lot of stuff. It's good for fragmentation, and it's not a lot of code. And adding and removing memory pools is cool too. This is actually the TLSF. The reason I found out about this is because espressif uses it for their allocations in esp-idf 5. Raspberry Pi devices under processor family. Okay. I should say if you're only in the YouTube chat, there's also a Discord chat above me. You can go to the URL adafru.it/discord, https adafru.it/discord, to join the Discord channel as well, and I'll type that in the restream too. The roofer is calling me. Can't call him right now. David says I expected TLSF to be related to TLS. No, unfortunately, it's separate. And actually, Toddbot posted a link to this, but espressif also has their version, and that's the one that we actually use. They've added more functionality to it, and as you can see, I also sorry, I'm going to text the. I'm in a meeting. What's up? Yay, live streaming. So we actually use the espressif version because I think it's more actively maintained than that Matt Conti one. But the espressif version is based on the Matt Conti one. So there was this issue that was filed on the Adafruit Learn repo. So if you don't know, like a lot of our Learn code is now available here. And it's this DVI one. Oh, yeah. Sorry, I have roofers at the house, and they called because the power flipped off. Oh, okay, Becca's there too. Sorry. Sorry, I know this makes for great. Great TV. It's like, they're used to me being there. Deep dive on the joys of home ownership. Oh yeah, we're like redoing the whole roof under our rooftop deck. And I think they're really trying to get it going because it's supposed to rain tomorrow. They're trying to get as much done today as they can. It's good though. They found like rotted out plywood below the deck. So yeah, it's good. Okay, so I don't think it's open. It might be this closed one. Yes, this is one. So this was filed and it commented about how like it was a memory error, memory allocation error, and it was happening even though we were releasing. So with the DVI example, it's one big allocation, and that allocation actually is happening outside of the Python VM because the display stuff lasts longer than the Python VM. So Tim had this theory where like something was causing it to not happen, but what I found is that no other allocations were happening between the free and the allocation, but it still couldn't apply. It couldn't fit in the exact space that the first allocation had, which is very weird. Like you would think that with an allocation thing, yeah, they'll figure it out. Or I can... Sorry, I'm gonna just add... Can I add somebody? I don't know. Sorry. What other options of microcontrollers are there? Ooh, there's lots. There's a good learn guide. I'm going to assume that they're adults and they can figure it out. There's this how to choose a microcontroller guide. A gentle guide to choosing kinds of microcontrollers. Simple boards. This is kind of old. That's not the one I'm thinking of. I think what CircuitPython board is right for you might be a better spot. Taya says that's really weird. It like it should obviously fit. I wonder if it would fit in 1 byte less or something. Curious how the garbage allocation works. Well, so I fixed this bug. And I will tell you exactly why this didn't work. And I actually made a pull request to espressif because their implementation has this problem too. I don't think they hit it as much because they're running on like multi-megabyte things. So we got pretty lucky where it was just like, we have a relatively small heap and then we like replicated it exactly. So there's these papers about tlsf because it comes out of academia. So they wrote papers on how it works. But the key detail and what comes in the name is how they find the free memory. So they have 2 levels of basically bitmaps, so these are all 32-bit microcontrollers. So, a number is 32 bits. And there are these assembly instructions that can tell you where, what position the topmost bit or the bottommost bit is set in. So it's a neat hack where they, Sorry, I just got a doorbell notification too. Let me share. It looks like she's there. How do you share a contact? I think the roofers got used to us being there because Ari was sick last week. So we were home all the time. It's annoying. Okay, they both responded to me. Like they can't work if there's no power on the deck. And they did this yesterday or something, like they used too much power or flipped the breaker or something. I did not read the whole paper, but I get an idea kind of like based on the particular pieces of it. So they use these 32 bits. So they use a 32-bit number and they use these assembly instructions to find the like next set bit. It's like a constant time way of like finding the next set bit. So there's two levels. One level is which power of 2 memory size are you looking for? So that's what the first level is like. It's dividing. So you're trying to find a list of free blocks. So you're going to do it does 2 levels of indirection, and then it has a list of memory regions that fit that memory size constraint. So first it says, okay, which power of 2 are we looking? You know, are we looking between 32 and 64 bytes? Or are we looking between 64 and 128 bytes? That sort of thing. And if you look at TLSF, like they have a GPL implementation, the second link. And they talk about it as well. We use the non-GPL implementation, but they have one here as well that I think is what they use in their evaluation. So there's 2 levels of indirection, and then you find this list of memory regions that fit the size that you're looking for. The first level is these powers of 2, and then the second level is there's 32-bit bit masks for every second level section, and it divides that section evenly into 32 parts. So it's linear instead of the power of it. So when you are adding a region to this this bitmap, you have to say like, okay, how big is it? Depending on how big it is, you figure out what first bucket and what second bucket it goes into, and that's where it is. And you do that mapping either if you're looking for an allocation, you do that like lookup, or if you're adding another pool or whatever. Yeah. So there's a caveat or a trick here that they talk about, and they even find, they have like pseudocode mapping insert. And they talk about like coming up with FL and SLs, like first and second level. And they have this mapping search function. And if you look in the source code, there's one called mapping search. It's basically the same thing. But what it does is it rounds, or at least there's a version of it that it does rounding. I don't see the rounding here. Actually, no, that's what this is. So R is equal to R plus this thing. So this is still not quite right. But the idea is that once you've found that list of regions that are the right size, I'm not explaining this well. It is complicated, so don't, yeah. So you can't express all of the different sizes in this scheme, right? If you're doing a power of 2, you're doing a power of 2, and then you're doing a kind of like which bucket of a 32nd of that range are you talking about? So the bigger your allocation is, the more kind of like less granularity you get in terms of like which region size you actually want. Anyway, so let me go the other direction and say, so what was happening is I was adding prints to the code, and I was looking at the first level and the second level numbers that were being used. And the numbers were different between the free. The free was giving one number, and then the allocation, when you're looking for a region that way, you look kind of at a starting first and second level, and then you look bigger, because it's okay to allocate to a bigger region. What you do is you just like you allocate to that region, trim it, and then give back the rest. So you like figure out what your minimum is, and then you look. Tyus says different buckets depending on if free or allocate. Weird. Yeah. So and that's the problem. So that's why. And not only were they different buckets, but the freed bucket, the bucket that the memory was freed to was lower or like smaller than what it was looking for. And the reason is that when you do the allocation of the region, you actually have to allocate the minimum amount or the maximum amount. Michael, good morning. Memory allocator today. That's what we're starting with, but I also have some interesting build stuff that I was working on and playing around with. So yeah, those are the weeds. Kind of this is the like giving myself a little time to play and think more broadly about stuff. I think the thing that maybe I need to refocus on next week is the USB host Featherwing. It's kind of like the next thing on my list if there's no big bugs that come out of the release candidate. But I'm giving myself a little time to play and experiment, which we'll go into more later as well. But I found this, I find this really clever. This TLSF stuff is really clever on how it works, and clever can be dangerous and hard to implement. So yeah, so this mapping search, the problem is that in the Matt Conti implementation, this R, which is a terrible name, the R is not it's not updated, or it's not returned back out. So what was happening is that when you allocate, it looks for this rounded version that's a little bit bigger. So the guarantee of when you get to a bucket is that all of the regions in that bucket or in that list are at least as big as the number that you found. So that's why you round up, is because you take a number and you have to round it up because your free lists don't have like infinite resolution. You only have that like two level of resolution. So you round it up and you look and see, oh, is there any free region? And any free region there you can use because you know it's at minimum that size. But when you allocate that minimum size, you actually have to, it's so hard to explain. You actually have to allocate the rounded amount. In order to have this property that failed, was that if you allocate the same amount again, you want to find that region again. And it's not, they do talk about it. They talk about this fragmentation stuff. Oh, this problem, the existence of free blocks of the requested size that cannot be found due to the search policy may happen quite often. the allocation of a block size cannot reuse any of the already existing 40-byte free blocks because they're in the wrong list. Any free block whose size is not a power of 2 cannot be reused to serve a request of the same size. TLSF solves this problem using two policies. There are more segregated lists, therefore the gap between segregated lists is much smaller. So this is the math for the like power of 2 plus the fraction of 32. Zarnlin says, do they talk about defrag option to condense free RAM? So they don't talk about defragmentation because defrag actually moves data. So like when your hard drive defrags, it actually moves the blocks because it has like all of the pointers. But they do talk about, what do they call it? So when you free space, it automatically grows to any adjoining free space. I forget what that's called. And then the second bullet point is the one that the implementation wasn't doing correctly. So round up the requested size to the next segregated list size. This way, when a block becomes free, it will be placed on a list where it can be found later for the same size request. And this is what we were not doing, what the implementation does not do correctly. This policy converts the original problem incomplete memory use into a classical internal fragmentation problem, which the worst case fragmentation is about 3%. Yeah. So it's interesting. But basically, so what was happening is that when it was searching for the block the first time, it said, okay, like here I found this free chunk. And then, but when it truncated it at the like requested amount, not the rounded amount, which meant that if you allocated something after it and that was still there, the spot was not big enough anymore. Anyway, I've explained it a lot of different ways. Does anybody have questions about TLSF that you think I could answer in a clearer way? Anyway, I fixed it. And actually, I'll show you the fix. So here's my pull request to espressif, and we're already using this implementation in CircuitPython now. Here's this mapping search function, and originally the size was not modified by it, even though, yeah, so how did the pull request work? Okay, so here's the mapping search implementation of this library. And even though we look in here, mapping search in their pseudocode is an in-out. It was not an in-out, so to speak, in here. It was not mutable. So I made it modifiable, and now we modify it. I corrected the rounding. So originally the rounding so if you're like 32nd of the range is like 4K, which is what it was in this case, it would just add 4K and like make it completely 4K bigger. But what you actually want to do is like you're actually rounding, so you want to like add the remainder, so you can leave a little bit more left. And I had to propagate that through a little bit because this block locate free is new in this implementation. So you take the adjusted size, so it aligns it once, and then you locate a free one, and this will adjust it further. And then by this point, now you've found the block where you're going to do it, and now you just then you trim it. So yeah, that was a fun bug, and I was like surprised that I figured it out, but it's quite clever. And I found another implementation that's BSD licensed, and they had the same problem. So I filed a bug with it's also based on this, also based on the Matt Conti version. So yeah, so it gives you the property. We now have the property that when you do an allocation, you're able to free it and allocate it again. But the consequence is that you actually are allocating more memory at the start. So the like allocation size that we do now actually does grow a little bit. But that means that we can reallocate in that space again. And the amount that the allocation grows scales with how big the allocation is, which I thought was quite clever. Yeah, so I think TLSF is really cool, and I'm all about it. And I was already like, my brain was already thinking like, could I use this? So like the CircuitPython, the Python VM heap is nowhere near as smart. So the way that the allocations work in the CircuitPython world is that it will basically like linearly search through until it finds a spot that it can fit. And a linear search is quite slow. Whereas like the nice thing about TLSF is that it's it's like a constant amount of time, right? Like, so yeah, I'm already thinking about like how to do TLSF for the Python VM. It's something that I need to talk with Damien and Jim about, because TLSF is quite clever. Right, because it's like, it's one 32-bit number for the power of 2 buckets, and then for every power of 2 bucket, it's another 32-bit number. So the overhead is really small. DCD asks, you had some memory allocation graphic visualizers a few years ago in a deep dive. Did you use that to observe the TLSF behavior? I did not. The way that I debugged it is I just added, so in the CircuitPython source, the place that we do these allocations is in supervisor for everything except espressif. Supervisor shared port, I think, or memory. No, port. Because a port can override it, but the idea is that like you want port memory. So there's this port malloc and port free, which is what we call. I just added prints here, and so I could like see that there was like a free to a pointer, and then immediately like this other allocation that was the size, and I added more prints so I knew the sizes of everything. But yeah, that's how I kind of like found that like, yeah, we are actually doing this like straight up freeing a region of one size and then immediately trying to allocate the exact same size, and it not failing. And then these TLSF free are submodules, and so I just looked at those, or I just added prints there as well, and that's where I printed out like the FL and the SL, and that's how I found that they were different numbers. So I was very pleasantly surprised about how quickly I figured it out. But yeah, TLSF is very cool. Because it's faster. Yeah, low overhead, pretty fast. Yeah, TLSF was initially developed under an EU grant for open embedded systems components. Yeah, very neat. Very clever. Like it uses like assembly instructions, so like it's really quick to. But you have to do, because you have like this minimum FL, SL you're looking at, you do have to do like a shift and then find. But it's really, yeah, it's pretty neat. It's a whole lot better than what we do in CircuitPython land. But then again, like CircuitPython has other things that it has to do. Like even if we made allocations faster, like the collect process would still be quite slow. So like, you may be optimizing the wrong thing in that point. Anyway, quite neat. Any other questions on TLSF before I dig myself out of this hole? Is it me or does the stream look fuzzy? Double check that you're running at the highest resolution. I have it set to 3,000 kilobytes per second, which is not the most, but oh know what? Can it support defragging, or is it just general no-no to move memory? It's a general no-no. The only way, the systems that allow you to do defragging or memory moving basically don't give out raw pointers. What they do is they give out pointers to pointers. And then you have a giant table of pointers. Because tracking all of the locations that have it is a huge pain. Yeah, and in fact, we, years ago maybe, when I talked about how we do long living, we used to do long living. So we used to put things on the other end of the heap if we thought it would be around a while, trying to get it to be more compact. But we actually, before we did the MicroPython update, we removed that because it was complexity that we didn't know if we were going to keep around, especially because we knew the split heap stuff was coming. So CircuitPython 9 no longer does the long living stuff. And the long living stuff had the same problem that we did move memory. We were moving stuff. Yeah, David says, yeah, and Tyeth are getting at an MMU can give you virtual memory to move it around. Yeah, but like MMUs are going to operate on like much bigger units. So I don't know. Okay, so another thing I did, since we're talking bugs, is improve RGBMatrix reliability, and I updated the IDF. So let's see, what did I actually change? So they released 5.13, so I updated to that. I had to disable this to fit. I realized the panic handler wasn't in IRAM, and I was debugging a problem with what it turned out to be is that if the flash file system is being written, then you call code that's on the flash file system, you crash, and you get a much better error message if your panic handler is in RAM when you do that. So I turned it on for debug builds now. It's like, I don't know, maybe it was, I thought it was on before and now it's not on again. But what I figured out is that there was this NP-hal delay microseconds that was being called by the protomatter stuff. So on the RGBMatrix, there's this interrupt that's running to update the matrix. And even though we have a check that says, hey, is the cache disabled? It turns out that check is not perfect. I think there's a race condition. I filed I wrote on the forum post where I found out about this, but basically they have a function that you could say like, hey, is the cache disabled? But it doesn't account for whether like code already started the disable process, but it hasn't finished yet. There's a race there, which is annoying. Anyway, so we were getting into this code that wasn't safe to run when Flash was disabled anyway. And the reason is because this is being called, so I fixed that. So I put this delay call into IRAM as well. If I've talked about making the compiler want to do this for us. So being able to say like this function needs to be able to run from RAM, and then everything that a function calls should be put in RAM, but that doesn't exist yet. So all this IRAM adder stuff is like scattered everywhere, which is quite annoying. And then this is just a tweak to TinyUSB that I thought might have been the problem, but it wasn't. But RGBMatrix should work better in the release candidate 0 because of this. And then there was a watchdog problem that I think Anecdata found where the like timescale was wrong. And so I just went in and changed some things with watchdog. This times 1,000 was the thing that was wrong. But I also added a warning on NRF, and I deleted these. These are really tricky. If not, self timeout is less than new timeout, or timeout is greater than new timeout. It's a weird way of saying if they're not equal, or if they are equal, which is silly. So I just changed the documentation to say if you set the timeout, it'll also feed the watchdog. So yeah, those are the bug-related stuff I did. Any questions before I move on to the builds portion of things? let me show you the other weeds that I've gotten myself into. But they're fun weeds for a little while, at least. Take a pause. Put some chapstick on. Take a drink. So before you could change the walk.time timer without affecting its last feed time. No. The only thing this check was doing is that if you set it to the same exact time, you wouldn't. So it only didn't feed the watchdog if you gave it the same value, which I think is actually confusing. So I think it's better that it resets if you set the same value again. Memory saving tips. I don't know. I don't think I've ever looked at that guide. We could look over it quickly. Zarlin asks, which esp-idf are you up to version-wise? So we are on 5.1.3 in the release candidate 0, even though 5.2 has been released. I was just looking at this. So I kind of expect that we'll do 5.2 with a 9.1. Oh, and look, they have a 5.2.1 now. So yeah, we'll do 5.2 pretty quick. They changed their I2C API, so we don't want to do it with 9.0. 5.2.1, 4.4.7, 5.1.3. So yeah, we're on 5.1.3, which is relatively new, but we're not on 5.2 yet. I think we'll probably do 5.2 pretty quickly because there is a C6 feather coming. I don't think that's secret. Like Dan just made a define on that, but there's all sorts of fixes for like, oh, I guess there's S3 fixes here too. BLE we're not really doing, but there's a lot of C6 stuff in 5.2, I think. So we'll do 5.2 pretty quick here, I think. Shouldn't be too bad. Yeah. Yeah, give it. DJ Devon 3 says, looking forward to checking out the RGBMatrix improvement. I can definitely put it through some paces more than most. Have a wall of panels. Yeah. Hopefully it's as good as the like earlier. There was a little churn in RGBMatrix as I updated the timer API, which is what caused this issue in the first place. So it's like introduced in beta 1 or 2 and then fixed in RC0. It wasn't this issue wasn't there that long. Like Liz, there's a closed issue that Liz did. So yeah, we're on 5.1.3, but we'll probably do 5.2 in the next month or so. Okay. Oh, and you know what? I missed David's comment about licensing. I can tell you a little bit about that. Despite coming from MIT, Lydia does not talk much and avoids the GPL FSS RMS. Not sure I want to ask a question about that and ask an engineer. Yeah, I'm sure she's got opinions about the Free Software Foundation and RMS, but generally she's totally cool to do GPL code, but I used to work at Google, and I saw that like the Google engineers are much like the Google like companies are much more willing to work on non-GPL code. So I find it hard to GPL license anything that I work on. Like, yeah, there's a risk that they like fork it internally and don't give back, but they're not going to do that with, unless your GPL code is very valuable, they're not going to use it. And then they'll never help you at all. So I think that's the trade-off. And then like MicroPython is MIT already, and there's PyCom, which is now defunct, like did do this like hybrid GPL MIT MicroPython stuff, but generally I follow the license of an existing project if I'm working in that space already. So yeah. Okay, so let's talk about build systems, because this is something that I was working on earlier and going like, yeah, this could work. This is kind of a fun Friday topic. It's not I'm going to spend all week next week. Probably not. I think Lamore will probably be like, don't do that. It's not that important. So I saw this go by on Hacker News. I think that's where I saw it. A simple and pleasant build system in Python. So I've long wanted a better build system for CircuitPython. And my main gripe with build systems has been DJ Devon3 says, if you ask anything licensing related questions during Ask an Engineer, you're likely to trigger a great PT rant. It's true. And Lamore rant. She could rant about it too. So I've been wanting a better build system for CircuitPython for quite a while. I've looked at Ninja for a long time and said like, oh, I could just generate Ninja. It frustrates me to no end that cmake is what people use, because cmake ends up getting used like a Python script should. I sent Dan this link. So my ultimate goal, my high-level goal, is that we could use kind of like the same build system and toolchain for all of our builds. So it doesn't matter if it's a ESP-C something where it's a RISC-V core or an ARM core. Like I'd prefer to just like have one build system, use one compiler, and just build what I want. And I'm okay building everything, building all of the like libraries when I need them. So I've looked at Clang. Clang is really like cool. Clang is a C compiler. It's like GCC, but going back to my licensing topic, LLVM is the larger project that Clang comes out of, and it's more liberally licensed. It's not GPL code, which means that there's lots of people from industry working on it. And the cool thing about Clang is that you can build it in a way that you can compile the RISC-V and ARM from the same binary. You can include it all in the same thing. So if you hear about like hacking on a compiler, people say that like LLVM is much more modern code. It's much more, it's easier to get into. And one thing I've found, like, I've had to fix so many of these issues, like this RGBMatrix thing, where we have a function we think we can run in RAM, and because of some dependency, it doesn't actually work. And that like, this is a problem that's solved by the compiler. And then furthermore, we have this problem, especially on the IMX, where it's like, I'd also like to be able to say like, I also have this really fast memory that you could put some stuff in and like let the linker work on that as well. So I wanted to dabble in, and I've started dabbling more and more into compilers and linkers. And so I really want to switch. I want to switch CircuitPython, at least parts of it, over to Clang, because secretly that's what I feel like it can actually hack on and potentially build features into Clang that benefit CircuitPython and embedded in general. Because I think I'm going to write this up sometime soon, but like there are so many hacks that happen in like these SDKs because the compiler doesn't do things that could be helpful, right? Like the Pico SDK and the IMX SDK and the ESP SDK, they all have to manage like marking functions to be in RAM if you choose to, and you have to know whether you want to choose to, and like it's all like super fragile. It's all custom. And so, yeah, so my goal is to like, I'd like to switch CircuitPython to at least be able to build for Clang. And I've got some changes for that, and I'm getting a little further afield from that. But then I also would like to move to a build system where we can stop rebuilding everything for every board. So like we have so many, like the CMD21 and their RP2040, they're both Cortex M0 cores. So like the assembly language that they run is the same. So in theory, we could compile many files that are all used, that are like, don't care what board they're on or what port they're in. We could compile them for the M0 Plus and just do it once. So I've wanted to also move us to a world where we can better start isolating different parts of the CircuitPython and MicroPython code base so that they only know certain subsets of information. Right now, the way that our make files work is that we basically have one big string of C flags that apply to absolutely everything. And that like is really bad for isolation. It's good for customization, but it's bad for isolation. So yeah, and then people point me to, oh, you know, it wasn't this one. It was the ARM repo. ARM embedded toolchain for ARM. Then like cmake is kind of like the de facto standard for this stuff. And then I just look at cmake. Cmake list files are like the make file of cmake. But then you get down into these weeds where it's like, I defined a function and I'm doing string manipulation, but it's all in this like weirdo language. And I just, every time I think about doing cmake, I'm like, why? Why did you do this? Like, the people that use cmake, they write Python scripts on top of the cmake so that you don't have to deal with it. Like, it just drives me bonkers. So for a long time, I've been thinking I need Python that generates Ninja. So cmake actually generates Ninja files and Ninja actually runs the builds. And I'm like, okay, great. Like I can just use Ninja and that's what that is. But I was looking at Hacker News and I saw this Hancho thing go by. And its build is a simple, pleasant build system in Python. And I'm like, huh. That's interesting. You know, for years I wanted a new build system for CircuitPython. Maybe this is the one. Python generates a cmake, generates the Ninja, cut out the middleman. Yeah. That was originally my approach for a long time. My hate for cmake has gotten a lot less since the more recent releases that change a ton of stuff. The other gripe I have about cmake and the other build system that is quite popular and picolibc uses is called meson, M-E-S-O-N, or meson. I think Dan corrected me because it's like a particle, and he would know what particles are. My main gripe is with meson, at least, you still have you don't have a holistic view of the whole world. You instead like have to set what cross compiler you're running and stuff. And in fact, picolibc, they still have a bash script that you have to run to call meson. It's like, drives me nuts. Yeah. I should have titled it Scott Rants About Build Systems. The other thing is like when I see like the Pico SDK, you set a flag that says like, you know, platform or build or board or something, and then it like siphons you down into this rabbit hole of like, this is the only, like, you do separate build directories, which is great, but like that build directory is not shared if you do another board, which I really like is one goal I want, is like, I want to be able to say like, okay, here's all the board specific stuff, here's all the port specific stuff, and then here's the rest of the stuff that only cares what compiler you're on. Rants logged in the time codes. And like all that stuff that is like just dependent on the CPU, like that can be shared across boards and stuff. So yeah, I've not seen somebody actually solve this problem. It's a problem that is like pretty unique to CircuitPython because we're like one of the bigger projects in terms of number of boards that we produce. And then for every board, we also produce like 12 different translations, which is something I was like thinking about fixing, and I was like, wait. Like, I gotta stop myself a little bit here. I have an idea on how to make that faster. Okay, So I saw this thing go by called Hancho. Turns out this person actually, aapleby, we used to work like on a neighboring team to me at Google when I was there. And just, I looked at his LinkedIn and he like left Google a year ago to do his own thing and was on Maps the whole time. So yeah, so I read this and it's like, it's just Python. There's no installation, but like the issue here is like, put on PyPI. But it's inspired by Ninja and Bazel, which is like Google's open source build system that's like written in Java, and I had no desire to deal with. But Ninja I like a lot. It's super simple. So it says, like Ninja, it knows nothing about your build tools and only tries to assemble and run commands as fast as possible. Great. Unlike Ninja, you don't need a separate build rule invocation for every single output file. Also great. I'm not sure. Right, I think, yeah. Like Bazel, you invoke build rules by calling them as if they were functions with keyword arguments. And you can create build rules that call arbitrary Python code for better or for worse. And it should suffice for small to medium-sized projects. And I consider CircuitPython is quite large, but I wouldn't call it large in like the build world or the compiler world, because if you like follow the LLVM people or the build people, they're talking about building things like Chrome or Android, where it's just like millions of lines of code and like megabytes and gigabytes of data and stuff that they're dealing with. So CircuitPython is complicated, but I would say that it does fit this bill of like, it's not super huge. So, and what's cool about this is like, it's just Python. And I actually looked, well, let's just pull up the tutorial. Would building the Linux kernel be considered large? Yes, for sure. I mean, the Linux kernel is still like multiple hundreds of megabytes. And it's certainly complicated. Like they have all the kconfig stuff, which is a separate thing of like, how do you... So I did have a discussion. I had a discussion with Dan about this because I was thinking about it again. And I said, like, I know I'm not supposed to go down this rabbit hole, but I kind of want to. And I was still thinking about the like Python generates Ninja and then you run the Ninja. But I had mentioned like, oh, in the build directory, so we have ports, port name / boards / the board name, and then you would have like some configuration file in there. And I said, oh, let's make it TOML. And Dan was kind of like, well, if you're going to use some system that's Python, why not just make it all Python? And I was like, And so when I saw this, I was thinking about this yesterday, and I thought, so they have these Hancho files, but they're basically Python. They are like slightly different in terms of how they're loaded, but they're run basically as Python, like their actual Python code. So, and I think I'm abusing it a little bit, but I'm very curious about this. So, so so his example is, aappleby's example is actually compiling C++ code, which is really cool. So that you just like create these rule classes and then you tell it what files in and out you are. Files in and files out are optional. This also works. Oh, the keywords themselves are optional. And so it has this like, templating engine that's not Python. So yeah, I've found I have to be a little bit careful of that. But yeah, so then you do hancho.py, and then you give it the Hancho file, and it rebuilds stuff. And then if you run it a second time, it doesn't do anything. So it is doing some detection about like whether stuff is new or not. What is the link to this page? Copy. Timon says, Zephyr also uses Ninja, by the way. Zephyr uses the Python West command on top of cmake, which then generates Ninja, I believe. It's not Ninja directly at all. It's like layers on layers and layers, and the top layers usually Python. Like that's true with the esp-idf as well. Like all their tooling is Python at the top level. So the cool thing about this is that it's all Python. There's no like underlying tool, and it's actually quite clever. We'll get to why it's so cool, or another thing that's cool about it. So compiling a C binary, they get a little bit further. So you compile and link. So you say compile, and you get something that represents like the output, and then you can pass that in. Wes is a little automation tool, not a direct dependency. But you don't run Ninja directly. I'm sure there's cmake there still. So now it has 3 steps. Yeah, bumped into Scon's, a build system written in Python, but while others liked it, it seemed difficult to start out with. Yeah, I never did look at that. And Dan talked about that a little bit too. And I think that was where his point of like, was coming from, was like, Scon's was just like all Python. So yeah, this is just talking about like header updates. So this is a weird thing about compiling C, is that you can actually have the compiler tell you what header files it included, so that the next time you run it, you know what header changes will cause you to have to update. So he talks about doing that, but before we go into detail, let's talk about what a rule is. It's a Python dictionary with a text templating system tacked on. So your command is basically just gets stuff substituted into it. And you can inherit fields from other rules via extend. Global stuff can go in a config variable. Infinite stuff will fail. Global configuration. This was interesting that the reason I think that aappleby's decided not to have them .py files is that they do play some tricks. This says we're globbing CPP in this directory, not the tutorial directory. This is not how Python module loading works by default. So it's doing some tricks to make sure that it's basically running Python from the directory that it's in, which makes it a little bit different. Instead of Wes build, you can alternatively run cmake. Okay, yeah, but you're still doing cmake and then Ninja. Fair. You can, but you probably shouldn't if Wes builds the way to actually do it. Yeah, I mean, this is obviously my bugbear. Okay, so that's, I think, why, and it's kind of annoying. I've been writing a couple of these files, and I have to like manually say that they're Python files. And this is kind of the structure that they talk about, is that you have a top-level file that loads subcomponents. And then there's also like a reusable thing that you load. Do you have to hand build all the rule files, or does it have a system to help build them? Well, so it's all Python. So you can do things like they're showing here, like you can have a Python function that takes some files in and files out, and actually like does some logic to generate all the individual kind of like compilation calls. So the thing that helps you build all the rules is just Python code, which is like, some people would say your build system should not be Turing complete, but I find that like all the reasonable alternatives are very close to Turing complete, to the point where it's confusing that they're not. Like even I was looking at some, like the picolibc. I was looking at how they do builds, and they have this meson, or meson, And they still have for eaches and if statements, right? Like, yeah. Depends on your needs. In a more complex build pipeline, you might prefer to use them directly. Anyway, so yeah. At this point where I see something that looks so procedural, it's just like, I'm just going to use Python. I'm just going to use Python. It's fine. So yeah, this was really interesting because it's just Python, which is quite neat. Which is quite neat. And as long as you write your Python in a way that's still like maintains that isolation for the different things, you're probably okay. Wes is pure Python. Yeah, but Wes then calls cmake. Deshipu says programmers will turn everything Turing complete if given a chance. Yeah. So the cool thing that's underneath how this works is, where does it tell you? So what it's actually doing is it's doing async IO. So this fourth tutorial is saying like, oh, by the way, like you could actually, instead of calling a command, you could actually call a function. Why is my build system installing pandas and numpy? Yeah, I might get there, sorry. Because some people think pandas is Python. So yeah, the neat trick is that like what build rules are doing is that they're you're actually doing async IO. So the way that you get like concurrent build stuff is that you're actually just running a bunch of like async IO tasks concurrently. So like all your concurrency stuff is basically like different async IO tasks that are like running subcommands. Pandas are usually much more fluffy than Python. That's true. I'd agree with that statement. Okay, so I'm really interested in this, and I had this idea last night where what if, but can it run Doom? Python can. So I've been thinking about it from the perspective of like wanting to generate one big Ninja file where like there is one target for every board, and like you would just one big Ninja file that you would just say like Ninja the board name. But what I kind of have been doing is I'm putting a Hancho file for every board. Can the build system run Doom? Yeah. So here's my example. I have this branch for Raspberry Pi. So I'm starting with the RP2040 feather, and I'm replacing all the .mk stuff and makefile stuff with Hancho because I'm curious. And I shouldn't be spending a lot of time on this, but it has some very, very, very cool properties. And yeah, so in Hancho, I can load a separate file. So this is the board's Hancho. And now when I'm doing board configuration, I'm actually calling a Python function. But I can also use glob to see like all of the C files that are board specific, which I haven't done anything with yet, which is fine. So I can load like my ports Hancho file, and then I'm loading like a top level Hancho file. It's kind of similar to how our makefiles are set up. Like we have top level CircuitPython makefiles that kind of get imported from the lowest level. The problem is that it's make. So like you could actually do much better debugging and more expressive stuff by having this be a Python file. So I'm loading RP2040, and then RP2040 board is just a function. and then depending on the function, I'm doing things. And one thing I could do that is hard to understand in, or do in, I mean, it's not impossible, but you can do it. It's much clearer in make, is that, where do I have the, in the make file, we have this big long list of includes. So these are like all the SDK include directories that we want. And I was like, I'm not going to copy that list. I'm just going to say in the SDK, for every include directory, I'm just going to include it as a system header. And then I'm going to make this big long string that is, these are all the port specific flags. And I'll pass that into the CircuitPython board. So CircuitPython board takes a board name and a compiler, but it has a default value for the compiler. And it has port flags, and it applies port flags to the compile CircuitPython rule. So basically, yeah, I'm redoing the make files in Python with this Hancho stuff. And I'll show you how far I've gotten. It's not very far. So Python prints just work as normal, and then you get to this point where you're doing compilation steps. And unfortunately, we have Q strings. The Q strings part of building is complicated, and it's unfortunate. It is shared. It's all split out. It's just a huge pain. Hi, Paul. So basically, to start making progress on this, like Q strings is one of the big things that I'd have to port. And it's actually not the first time I've done it, but yeah. DCD, so after you get Hancho working, how will you be reorganizing CircuitPython to support sharing code across common architectures? I'm not as concerned about sharing code across common architectures so much as build artifacts. So I was thinking about this, and I can do it now in our existing layout. If I know for sure code is not board or port dependent. So basically, everything that's not actually CircuitPython code, I could start sharing pretty much immediately. Anything that includes npconfig is going to implicitly include npconfig port and npconfig board, and that will mean that it's basically board specific. So yeah. What about compatibility with MicroPython? Will there be much more work required to merge upstream changes? So, good question. I hadn't thought about that. Generally, our build systems are somewhat separate already. Like we already have the CircuitPy make file stuff that's in the Py directory that's unique to us. That's mostly around shared bindings. But yeah, that's a great, we still do use their makefile rules. I think they maintain both cmake and makefile rules for their builds. But yeah, I mean, potentially it'll move us into the case of when we update, we have to list new source files, but we can just glob to get all the source files and build them all, or try to be a little smart about it. So yeah, I don't know. The thing that I need to limit myself to that I'm not doing, because it's kind of annoying, is I would really like to get actual CLang support checked in. But what I run into with Clang support is that even though Clang itself can handle multiple CPU architectures, you also need 3 libraries that you need: libc, libm, and the built-in functions for your particular architecture, which is not something that Clang packages. And libm, we have a flag in micro that we inherit from MicroPython, and that we can like build it ourselves if we want to. But yeah, so I kind of want to move to this model where we actually just build all of the libraries we need. We're like very close. Like we actually have like there's a shared /libc folder. And that's why I've been looking at picolibc, because that's the direction folks are going. So I was thinking about, like, I can install Clang, it's pretty easy, but installing like all of the different like multi-lib sorts of precompiled stuff is quite painful. And I was playing around with it, building like there's a libgcc that GCC uses that gives you like, you know, like software division and stuff like that. Although that's probably in libm. But yeah, I was trying to fuss around with the LLVM version is what they call compiler RT, so like compiler runtime. And they have some things about like, how do you build the multi-lib stuff? And that's what this directory or this GitHub repo is doing. This one. So like this repo is about building a tool chain, where tool chain means compiler plus these like very little extra libraries that you need. And they talk about like all of the different architectures that it supports. And the reason that it supports all those different architectures is because it includes these precompiled libraries. So they have to like pull in picolibc so that they provide libc by default. So in order to be super versatile, I think I want to just move us to like, we don't need any other libraries. We just need the compiler. And ideally that compiler is Clang, and Clang can do it all. And then we'll actually just build all of the other stuff we need. Because like the built-ins that we need from like compiler RT is really like, it's 150 files. Like we can just build it. And we can build it exactly as we want it, right? Like we could build it with OS, we could build it with O3. We can build it with exactly like what processor we're on, with whatever floating point we want. Like we don't have to rely on finding some package that has that like built with the exact combination that we need. So these are the weeds I'm going down. I don't want to add the ability of doing that into our make files. So I'm getting a little distant because this Hancho stuff is, I wanted to test it out. That's kind of what today was. And I think I'm finding that it's pretty nice. Pretty nice. So yeah, we'll see. We'll see how quickly I can get it going. Like we have 30 more minutes here on the stream. Do we think I could get all the QString generation stuff going? It's actually probably worth talking about on the stream because it's in the weeds of how CircuitPython works. And it's actually in the MicroPython build that we largely inherit all this stuff from. Any other questions before I try to get QStrings building? Which is a scary task. So my hope would be that like once we move to this Python only system, we can actually like start to refactor things. So like I don't want to have just one compile build rule that gets all the flags, because I want to like scope flags down so that like if we're building stuff in the Py directory, it shouldn't know what board we're in. Right, like so that, and then once we can say like right now all of the build artifacts will end up in a board specific folder, but we should be able to start moving stuff out of that and then sharing it across builds. But that'll be, you got to be careful with that for like include headers and stuff. But I really like that it's Python because it's debuggable. Right, so there's this like, the board Hancho calls a port Hancho, and the port Hancho calls a top level Hancho, or top level function that then like generates all of these async IO tasks basically, and then they all get run concurrently. And there's this like already logic about like which are the new files, are the output files newer than the input file, all of the input files, and like only running the things that we actually care about. All the Hancho stuff is really changing. Like if you look at the repo, like he was working on it today or yesterday. So yeah, I tried to reach out to aapleby, but he hasn't got back to me. I think he's heads down on it. And I should actually look at the Hacker News article because I'm curious to see if he was engaged with that at all. How do I search? Can I search? Past. Go back a day. I don't know how to find it. Oh, you know what? I can look at my RSS feeds. Let me do that over here. Because that's all the way, the only way that I see it. I just do the RSS feeds. Do I search? Sorry, I'm trying to find the, here we go. Comments. Basically a promise-based dependency graph. Okay, so he was engaging there. I'll have to read through this to see if there's any more insight in what they're doing, but I won't do that on stream. There you go, thanks. Okay, let's do this. Let's see if we can't port the QString stuff. So what do I want to do to look at that? So let's just open the Py directory and we will just make some rules. If a developers have to ask what is the build system doing now means it is too complex. Yeah, I think it's, I mean, QStrings is one of the places where it's really complicated. Which is so frustrating. Is it in Py? Yeah. So like QStr global dependencies, global requirements. Like there's all this sort of configuration stuff that happens here too. Hey, look, you can do for each. it feels like, and then there's all these lists of files, which are just like unnecessary. What is a Q string? Thank you, Zarnlin. That's a great question. Intern strings, basically. Yeah, so you'll see them in the code as mp_qstring_. And they get converted to regular C string, or those things in the code get converted into 16-bit numbers that then are indices into a pool of strings, metadata about strings. Interned means that they basically get deduplicated across the whole code base. So they get collected into a big table of metadata, and it's actually a pool, so there's like multiple tables. And then all you have to store to know about a string or a Q string is the 16-bit number that it kind of boils down to. Which is nice because it's not a 32-bit number like a thing. So Michael's pointing out also translation. So we use the Q string mechanics to do translations as well, but those should be those are Q strings and translations are still separate. We just there's overlap in the tooling, but they are different. They're different. So like just like Q strings, translations do also get like kind of glommed all together, but Q strings and translations are separate things. So in the code you'll see mp error text and then parentheses and then a string. That's something that will get translated. That macro gets replaced with a function call, and the function compares this string as input to some data structure that is the compressed translation. And then Q strings, np qstir gets subbed with a 16-bit number, or there's a header file that has a pound defined for that thing that is a number. So yeah, this is a good topic. We don't have all that much time, but let's see if we can get into it a little bit. So we can get into it. Let's see. We want what file was missing? This qstir defs generated was missing. Building CircuitPython for a new board. How to instruct make board equals to build with the latest version of CircuitPython. You need to check your git status to make sure that you're building with, like, if you do git log, it'll show you the last few commits. It's not a function of make, it's a function of the state of your, it's a function of the state of your git repo. Okay, so this is looking for qstir defs generated. And so in the makefile world, this is how you define what you're doing. So this is kind of your rule, and then on the right side is your dependencies. So this is like definitely a test for how it makes it. So let's do qstir generated is equal to rule, and then the description is going to be generate qstirs. The command is going to be, so there's actually two commands here. There's this one, and then there's, and the Q is annoying. parameters. So this echo is just the like, I want to print out what it's doing. And then this is just, oh, it's running like sed. Okay, so this is qster preprocessed. Preprocess. Qsters. So I am going to try to split this out. Command equals. And I'm just going to do cat. And then this is just going to be, it's like, these are three different, let me just, files in equals. I'm just going to put this here temporarily. And so it's going to be files in and, oh. Oh, my window is not big enough. Said. Let's do single quotes instead. That doesn't help me. How do I escape? So C++, so this is going to be, so this, right, so it's, more monitors, wider monitors. Oh, I have a plenty wide monitor. The problem is that I'm streaming at 1080p, so I'm only keeping it in the corner where you can see it. This is going to be files out. Oh. If I do it there, maybe that's right. Yeah, Paul, like the help with Git channel might be the best, or CircuitPython dev is a good place to get help. It's not something I can easily help with during the stream. So this is a, I think this is, you're piping in all of the files, you're doing a regex, and then you're pre-processing it with your C flags, I think. Which I guess we have to do, which is annoying. And this is actually going to be compiler. And then the qster generated is Python. It would be neat. It would be neat if it would rerun this rule if that Python file changed. I wonder how to do that. Should have checked the YouTube resolutions. Let's do 1080 instead of 360. Yeah. Sorry, I should have been explicit about that. For now, let's not do that. We'll just do pi. I don't know how to handle that. And then this is files in, files out. Okay, so yeah, this system doesn't handle like files in files in will include everything as a dependency, even if you don't care for it. Just definitely not what we want. We could probably modify it. That's the other cool thing about it, is like we could probably just fix it. Or we could change it to do what we want. But that's more work. So now we're going to do qstir des equals qstir generated files in is going to be qstir pp stir processed. Files in is going to be some long list. Files out will be the qstir defs.generated h. No, that's not true. Let's copy. Oh, and my cursor stopped working. If anybody's using Wayland and knows why the cursor stops working, let me know. But yeah, I think it's pre-processed. Everything's working smoothly. Yeah, I actually downgraded the amount as you know. And then, yes. And then we make, yeah, so there's no way to handle, I wonder how it works. But I basically want to add deps that are not files in. They still need to be a dependency. Let's see if that's covered at all. Cursor disappear in Wayland. Yeah, I know. So, hancho. Pi. Docs. Oh, you know, not only is, yeah, this is a different file. Special fields. There's dep file. Oh, here we go. Deps, a list of files this rule depends on to run that are not input files. Ran out of Wayland cursor tokens. Got to get a pack of 800 for only 10 USD. If you're selling them, I could use it. I can restart Sublime Text and it'll show up again. Okay, so what I want is deps equals qstir deps. It's so nice that this is Python, though. I think that's something I'm having, like, kind of trouble with. Is that this is like, it's so nice. It's so nice that it is Python. Like, I can do so much of what I know. Like, I'm assembling flags using Python code. Okay, let's see what that does. I don't know what it'll do, but let's see. Okay. It gave me a big long Python exception. Invalid syntax, CircuitPython, Hancho, line 31. Oh, yeah. Ah, so there's also... header build as a directory. mpconfig.h. Oh, that should be... Yeah, so because it's not a C file, we also need to be able to tell it. Okay, so this depths thing means that we can tell it. And you can template depths, maybe? I wonder if you can template depths. Because then we can have a separate keyword or a separate keyword argument for like the Python file to run. But yeah, we can figure that out later. I wonder if we can do it here. Depths equals, well, this is going to take the compiler, and I'm thinking of this other one. Py.make qstr data. Cool. All right, let's fix our syntax error. My cursor. I don't know why that happens. Partial length line 49. I think this is because of that long string. Oh, maybe it's this long list thing. Let's make files in a proper list with my invisible cursor. Oh, you think if I resize it, it'll come back? Nope. I don't know why it disappears. It boggles my mind. Hey, it's running, it's just not finishing. That's interesting. I wonder how I could get it to not capture the output. I can run it in verbose mode. Would that not capture the output? That would be kind of neat. Ah, I'm catting nothing. That's why. Let's just choose main.c and see what happens. This is what happens when I can't see where my cursor is. I can't type. Oh, I was close. Somebody help me get my cursor back. I can restart it. That'll do too. All right. Empty preprocessor output. Command not found because I didn't tell it what compiler I was using. So E or -X required when input is from standard input. That's a good error message. I don't know what -E or -X mean. So it should just be doing pre-processing. Interesting. It's saying I'm rebuilding this thing because its Hancho file has changed, which is cool. Alt tabbing. That's assuming I know where the Alt key is. No. I don't know. I can restart it. Oh, yeah. So it's running the preprocessor. And this is kind of the problem. Is that we need to generate... We basically need to generate two... Like it's doing these like sed replacement. It's catting a file, setting it, pre-processing it, setting it again, and then outputting it to a preprocessed directory. And then it gloms it, well, no, it gloms it all together first, and then does that process. Which is weird. I think what I'm going to have to end up doing is not making it work that way. But instead, for every file that I know we're going to build, do this process of pre-processing and then glom them together after that. I think that's what I got to do. It's probably a better way to do it. Anyway. I'm in these keystring reads. I'm going to spend a little time in them. The question is like, are these keystring reads better managed from Hancho or not? MC Quinman says, is there a way to get my PC's memory usage free, CPU usage present, CPU temp, GPU usage, and GPU temp with Raspberry Pi? From CircuitPython, no. A lot of people do ask that if like CircuitPython devices can read more about the host. I'm sure there's a way to do it from within the Pi 4. I don't know off the top of my head. Zarnland is suggesting LM sensors. Oh, okay, so let's wrap up. And I remembered to notice I'm not here next week. So Foamy Guy is going to deep dive next week for me. Thanks in advance to Foamy Guy for doing that. Also, thank you to DCD, who usually takes time codes, and I think is doing that today as well. I'm going to wrap up, at least streaming. I'll see you all on Discord. If you go to the URL adafru.it/discord, that's where we're chatting all week and see how far I get in this adventure. If you want to support me and Adafruit, go to adafruit.com and purchase hardware there. Not only do you get hardware when you buy Adafruit stuff or from Adafruit, you get support and software and tutorials and all of that other good stuff. Please try 9.0 RC0. Let us know if you find any big issues. Hopefully the discussion of TLSF was interesting to folks. I found it really cool after I had my like, oh, that's how it works sort of moment. And if this Hancho stuff is interesting, yeah, ping me on Discord and maybe we can get that working. If you're in the like compiler Clang world as well, I'm there. My brain's there right now. So, yeah, so I'm not here next week. Foamy Guy is. I'll be on the Discord. I'm working all but Friday next week. So I'll be around. Any other things? I don't think so. Being back in 2 weeks is conditioned on not being healthy because I have a toddler. But besides that, thank you all. I hope you have a good weekend, and I'll see you all next week as well. And I think my window cam is the overhead cam right now, so that will show. Not too bad of weather, although I don't think I'm going to get out for a run. I should. But I think I'm going to work on this a little bit longer and have a snack. So thank you all. I'll see you on Discord. Have a great weekend.